Okay, let's start to solve these questions. Well, we can turn this question into 3x squared minus plus 3y squared and to find this max. And the subject is the same to the original question. Then we just to construct the Lagrange function like this. Then we just do the first order condition to the x and y, and we got these two functions. After that, we can get the Hessian of the Lagrange like this. And these three functions are the constraints. Next, we list the KKT condition, and these functions are all the KKT conditions which we should satisfy in the cases we discussed after that. Then we began to classify the discussion. First, the lambda 1 equal to lambda 3 equal to lambda 2 equal. In this case, we can get the x equal to 0 and y equal to 0. That's the start point, and the second order condition is this. We solve this determined is the 36 is larger than 0. This is the positive definite. So this is the local minimum. Let's move to the second. Lambda 1 equal larger than 0, lambda 2 equal lambda 3 equal 0. In this case, we can get two conclusions, and one of them, because lambda 1 is negative 1 over 6, so it is not satisfied the requirements. So this is no solution. We just analyzed the one of them, another one. So in these cases, we check the constraints and we find that all meet the requirements. So we do the second order condition. We got the border Hessian is this, and solve this determined is negative 24 y squared minus 1 is is absolutely less than 0. And we find the k is equal to 1 and n is 2, so n minus k is 1. So we can find the minus negative 1 to the power of k. We can find the sign of the negative 1 to the power of k is the same sign as the determined Borden Hessian. So this is the local minimum. And another situation, because the Borden Hessian is the same, so this is the local minimum. Okay, we move to the third situation, lambda 3 larger than 0 and lambda 1 equal lambda 2 equal to 0. In these cases, we can find x equal to y equal to 1 over 2. And then we do the second order condition, and we solve determined of the Borden Hessian is the negative 12 is less than 0. And we find the determined Borden Hessian, the sign of the determined Borden Hessian had the same sign as the negative 1 to the power of k, which k is equal to 1. So this is the local minimum. Okay, we move to the fourth situation, lambda 2 larger than 0 and lambda 1 equal to lambda 3 equal to 0. In this situation, we got lambda 2 is negative, so this is not satisfied with the situation lambda larger than 0, so this is no solution. Okay, we move to the fifth situation, the lambda 1 larger than 0 and lambda 2 larger than 0 and lambda 3 equal to 0. In this situation, k is 2 and n equals to 2, so n minus k is 0. So we can use the second order condition, and we can get this fourth situation and solved x equal to 0 and y equal to negative 1. So we just put x and y into the fxy and got the fxy is equal to 3. Okay, we get to the sixth situation. Lambda 1 larger than 0 and lambda 3 larger than 0, lambda 2 equal to 0. In this situation, we also got this two cases. And we can see in the first one, lambda 1 equal to lambda 3 equal to 0 is not satisfied. So it is no solution. We've just moved to the another one. In that situation, we like the same way above. We just put the x equal to 3, y equal to -2 into the fxy. So the fxy, we solve the fxy is the 39. Well, the seventh situation, lambda 1 equal to 0 and lambda 2 larger than 0 and lambda 3 larger than 0. In this situation, we also got two situations, and we use the same way like above. In the first one, we solve the y is equal to 0 and x equals to 1. So fxy is equal to 3. And the second is y equal to minus -3 and x equals to 4. So fxy is equal to 75. Well, let's move to the last situation. Lambda 1 and lambda 2 and lambda 3 or larger than 0. In this situation, we can solve the x or y, so this is no solution. Finally, we can compare this point, and we can conclude that the maximum is the point, max point is the point x equal to 4 and y equal to -3. So we get the fxy, the max is the 75. So the original function, the minimum is equal to -75. Yeah, that's all. Thank you.